applied to transformations that are parameterized by some.
Right. You have two experiments on comparing random samples.
I have some theoretical parts explained in the thesis and an idea of how to combine the two. I think RANSAC is definitely an algorithm for choice when you have a transformation, because you can use only 2 or 3 matches and you find the transformation, and all the others are automatically aligned. Right? The same thing with half transform. There is some kind of parameters there, some parameter space invoked. Spectral matching is for when you have, and also graph matching generally is for when you have some deformations, and in some cases you don't even have a model for this transformation. Even like really recently there is work where you have maybe PCA, some PCA space you have a model. But when you don't have any model, and with a lot of problems you don't have a model.
So it's essentially a non-rigid problem?
Non-rigid, and actually I have tried RANSAC. A lot of those examples that I showed you on cars and motorcycles, they may look affine, because you see all these lines that are kind of parallel to each other, so they look affine. And I definitely tried the RANSAC and it's doing nothing. You get 0 matching rate. So RANSAC is not going to work there. However, I think there is benefit in both approaches that could be combined. So for example, spectral matching could be used to get you get this eigenvector that basically is almost like a probability of these assignments being right. And RANSAC does not do well when you have all the possible assignments there. So you could use spectral matching just to get this idea of what the assignments are probably correct. Then keep, let's say, the best 3, the best 5 out of all, and then do RANSAC if you have a parameterized transformation. And as I showed in the thesis, there is a theoretical part where I showed how they compare. So spectral matching, let's say you have a transformation that is based on only on 2 matches, such as a rotation, and you have a graph that is sparser than the full graph. Then spectral matching turns out to be less expensive than RANSAC, at least in theory. Now, of course, there is a cost per iteration, but I have not checked that thoroughly. However, if I have a transformation that is parameterized by 3 or 4, then spectral matching is definitely less expensive. And then you can apply RANSAC as a post-processing step. So you use, because spectral matching is not really giving you all the correct assignment, it's giving you most of the assignment.